All right, I'm going to start reading the packet, but again, I'm only going to go for a few minutes every time because I don't want the video so long that it takes forever for y'all to download or look at, okay? So I'm just going to read some pages on each video and stop it when it gets to about 5 minutes or so that the videos don't get so terribly long, okay? So where I'm going to start is the size of the sun. We're going to see how far we can get, okay? And then, but as you're reading through it, you need to be thinking of the details because you got to write that glossary next week, week 2, and this will still even help you do your 3D version of your solar system, okay? So let me see if I can get everything. I don't want to zoom in too terribly much here because I want you to be able to see and hear at the same time, okay? But it says the sun or sol is the star at the center of our solar system and is responsible for Earth's climate and weather. The sun is almost a perfect sphere with a difference of just 10 kilometers in diameter between the poles and the equator. The average radius of the sun is 695,508 kilometers, which is 20 to 25% of its core. And then you have the size of the sun, and then the sun compared to the Earth, Neptune, Uranus, Saturn, and Jupiter. Okay, so it's kind of hard to see, but it lists those planets there. Facts about the sun. The sun is all the colors mixed together. This appears white to our eyes. The sun is composed of hydrogen, 70%, and helium, 28%. The sun is the main sequence G2V star, or yellow dwarf. The sun is 109 times wider than the Earth and 330,000 times as massive. The sun's surface area is 11,990 times that of the Earth's. The distance between the Earth and the sun is an astronomical unit, or AU. 1 million Earths could fit inside the sun. A hollow sun would fit around 960,000 spherical Earths. Is squished inside with no wasted space, then around 1,300,000 would fit inside. The sun's surface area is 11,990 times that of Earth's. The sun contains 99.86% of the mass of the solar system. The mass of the sun is approximately 330 times greater than that of the Earth. It is almost 3/4 hydrogen, whilst most of the remaining mass is helium. Next page, at the top, it says the sun is almost a perfect sphere. The sun will consume, let me go back up here. The sun is almost a perfect sphere. There is 10 kilometer difference between the sun's polar and equatorial diameter. This means that the closest thing to a perfect sphere has been observed in nature. The sun will consume the Earth. When the sun has burned all of its hydrogen, it will continue to burn helium for 130 million more years. During this time, it will expand to the point that it would engulf Mercury, Venus, and the Earth. At this stage, it would have become a red giant. The sun will one day be about the size of Earth. After its giant red giant phase, the sun will collapse. It will keep its enormous mass with the approximate volume of our planet. When this happens, it will become a white dwarf. The temperature inside the sun can reach 15 million degrees Celsius. Energy is generated at the sun's core by nuclear fusion as hydrogen converts to helium. Hot objects expand. The sun would explode if it weren't for its enormous gravitational force. The temperature of the surface of the sun is closer to 55,600 degrees Celsius. Light from the sun takes 8 minutes to reach Earth. The sun is an average distance of 150 billion kilometers from light, travels 300,000 kilometers per second. Dividing one by the other gives us an approximate time of 500 seconds, or 8 minutes, or 20 seconds. Or 8 minutes and 20 seconds. Although this energy reaches Earth in a few minutes, it would already have taken millions of years to travel from the sun's core to its surface. So what that's mean, guys, is that if the sun ever burned out, it would take us 8 minutes and 20 seconds to realize it, okay? We wouldn't be able to see it for that long. The sun travels at 220 kilometers per second. The sun is 24,000 to 26,000 light years from the galactic center, which takes the sun 225 to 250 million years to complete an orbit of the center of the Milky Way. The distance from the sun to the earth changes throughout the year. This is because of the earth travels in an elliptical orbit around the sun. The distance between the two bodies varies from 147 to 152 million kilometers. The sun is middle-aged. At around 46 billion years old, the sun has already burned off about half of its stored hydrogen. It has enough left to continue to burn hydrogen for approximately 5 billion years. The sun is currently the type of star known as a yellow dwarf. The sun has a very strong magnetic field. Magnetic energy released by the sun during magnet storms causes solar flares. We see these as sunspots. In sunspots, the magnetic lines twist and they spin, much like a tornado would on Earth. The sun generates solar wind. The wind is a stream of charged particles that travel at approximately 450 kilometers per second through the solar system. Solar wind occurs when the magnetic field of the solar extends into space. Facts about the Kuiper belt. The Kuiper belt contains hundreds of thousands of icy bodies that range in size from small chunks of ice to worldlets larger than 100 kilometers across. Astronomers have tracked most short-period comets from their origin in the Kuiper belt. These are comets with orbital periods of 200 years or less. There could be more than 1 trillion comet nuclei in the body of the Kuiper belt. The largest Kuiper belt objects are Pluto, Quintaro, Makemake, Humana, Ixion, and Barlurana. These are often referred as the transnucleon objects, or TNOs. The first mission of the Kuiper belt and beyond will fly by Pluto in July 2015. It's now called New Horizons and will survey Pluto, Charon, and the other moons before heading out to study other Kuiper belt objects in the future. Astronomers have found structures similar to our Kuiper belt around at least 9 other stars. Hubble Space Telescope images disks around the stars HD 138664 in the constellation Lupus and HD 53143 in the constellation Carina. The ice in the Kuiper belt date back to the formation of the solar system, and they contain clues to conditions in the early solar nebula. What is the Kuiper belt? The Kuiper belt, sometimes referred to as the Kuiper-Edgeworth belt, is an area of the solar system that is estimated to stretch across 20 astronomical units of space. It contains small solar system bodies made mostly of ices. The ices are frozen volatile gases such as methane, ammonia, nitrogen, and water. It is also home to the known dwarf planets Pluto, Humana, and Makemake. The Kuiper-Edgeworth belt is named for the astronomer Jared Kuiper, who theorized about the disk of material in the outer reaches of the solar system. Kenneth Edgeworth, who had the idea that the outer solar system became the name of small bodies, perhaps left over from the formation of the sun and planets. This region of space is cold enough to support the existence of volatiles more easily than the areas closer to the sun. The Kuiper belt location. The Kuiper belt extends from roughly the orbit of Neptune. The main body of this belt covers much of the region, ranging from nearly 40 AU to 48 AU. It is thick in most places, and astronomers have described it as being more torus-shaped than a belt would be. Other regions of the Kuiper belt include a disk of scattered objects that are part of a population of worlds called transnucleon objects. Facts about the asteroid belt. What other fascinating things do we know about the asteroid belt? Asteroid belt objects are made of rock and stone. Some are solid objects, while others orbiting rubble piles. The asteroid belt contains billions and billions of asteroids. Some asteroids in the belt are quite large, but most range in size down to pebbles. The asteroid 1 Sirius is also designated as a dwarf planet, the largest one in the inner solar system. We know of at least 7,000 asteroids. The asteroid belt may contain many objects, but they are spread out over huge areas of space, and this has allowed spacecraft to move through the region without hitting anything. Asteroids get their names from suggestions by their discoverers and also given a number. The formation of Jupiter disrupted the formation of any worlds in the asteroid belt region by scattering asteroids away. This caused them to collide and break into smaller pieces. Gravitational influences can move asteroids out of the belt, and the asteroid belt is often referred to as the main belt to distinguish it from other groups of asteroids such as the Lagrangians and Centaurs. What is the asteroid belt? The vast majority of asteroids in the solar system are found in the region of the solar system out beyond Mars. They form the asteroid belt. Others orbit near Earth, space, and a few migrate or are thrown out of the solar system by gravitational interactions. The four largest asteroids in the belt are Sirius, Vesta, Pallas, and Hygiea. They contain half the mass of the entire belt. The rest of the mass is contained in countless smaller bodies. There it was a theory once that if you combined all the asteroids that would make up the missing fifth rocky planet, planetary scientists estimate that you could put all the material together that exists today, it would make a tiny world smaller than Earth's moon. Where is the asteroid belt located? Let me see. All right, let's finish this page. The asteroid belt is located in an area of space between the orbits of Mars and Jupiter. That place between 2.2 and 3.2 astronomical units from the Sun. The belt is about 1 AU thick. The average distance between objects in the asteroid belt is quite large. If you could stand on an asteroid and look around, the next one would be too far away to see it very well. Asteroid mining. The solar system contains many different types of asteroids grouped by the minerals they contain. The abundances of precious metals such as nickel, iron, and titanium, to name a few, and water make asteroids an attractive target for mining operations when humans decide to expand their presence through interplanetary space. For example, water from asteroids could serve colonies in space, while the minerals and metals would be used to build habitats and grow food for future space